Let's suppose that we take just 5 pings and we use a packet size of 100, just as a round number to make things simpler. We might get ping results like these. Hypothetically, like 22 milliseconds, maybe one of them goes really fast, 12 milliseconds, 45 milliseconds, and so on. If we use a different size packet, then we might get different times. We might get, say, 14 milliseconds and up for that kind of packet. So when we consider these different kinds of numbers, why is there variation, and where does this overall delay come from? We can start looking at our calculation of propagation plus transmission plus processing plus queuing. And we know that the propagation delay is going to be the same for every packet to a good approximation, independent of the packet size. So whatever that delay's contribution to these measurements is, it'll be the same for both the 100 and the 200 size packets. So I've drawn that as a beige bar here at the beginning. The next part of the delay, transmission, that part is proportional to the packet length. So I've colored in some segments of the bar here in blue to represent that transmission delay, and the blue part needs to be twice as big for a packet of size 200 as of 100. The processing delay we treat as 0, so it doesn't show up in these bars at all. And since queuing delay is all that's left, then we just allocate the rest of the bar to that queuing delay. And that is where the variation comes from, right? The others can't change because they were properties of the packet size and the destination. So they would be the same for the same packet size or vary in a predictable way for a different packet size. Queuing delay is going to be where all the variation is. And so we just guess that our fastest pings correspond to a good case when no one else was busy and the packets could just fly through. So that would be when there was no queuing delay. And then the longer ones, including, say, the longest ones, that's when things happen to be busy. And we just infer that that was a long queuing delay. So from these sort of measurements and from the assumption that the fastest one was the best case scenario with 0 queuing delay, we can work backward algebraically and figure out these other propagation delays and transmission delays for a particular destination in our network.